Welcome to Mickey Study Circle channel. In this video, we shall see how to do the computer drafting of the orthographic projection of planes. Coming to the problem statement. A pentagonal lamina having sides 25 mm is placed on one of its corners on HP such that the perpendicular bisector of the edge passing through the corner on which the lamina rests is inclined at 30 degrees to HP and 45 degrees to VP. Draw the top and front views of the lamina. So we can arrive at a set of conclusions here. So the given type of polygon is a pentagonal lamina, and each of its side is measuring 25 mm. And the initial resting condition is it is resting on one of its corners on the HP. And also the condition with respect to the HP is the entire surface of the lamina is inclined at an angle of 30 degrees to HP. But however, when we come to the inclination with respect to the VP, it tells that the perpendicular bisector of the edge passing through the corner on which the lamina rests is inclined at an angle of 45 degrees to the VP. So here obviously the distance of the perpendicular bisector in the initial position is going to be more than that compared to the distance of the perpendicular bisector in the second position, that is when it is inclined to HP at an angle of 30 degrees. So obviously this perpendicular distance when aligned to the VP is going to take an apparent angle. So we need to construct the apparent angle, that is the beta angle. So the given angle here is 45 degrees. If at all the question ad appears to be inclined to VP at an angle of 45 degrees, the given angle itself would be the beta angle. However, the word appears to be is not used here, so we need to construct the beta angle. So now let us begin solving the problem by drawing the XY line of thickness 0.18 mm. So let us draw a line of thickness 0.18 mm and annotate the line to be the XY line. And we should also annotate the reference planes as VP and HP. Now we will construct the pentagon and then align it as per the requirement. So the pentagon is going to measure 25 mm. The first angle will be 0. The next angle will be 72. Next, the edge length is 25. The angle is 72 into 2. 25 is the edge length and the next angle is 72 into 3, followed by 25 as the edge length and 72 into 4 as the angle. So this completes the pentagon. So now we will align it in such a way that it is resting on one of its corners on the HP. So to have a perpendicular bisector, we need to have one of the edges perpendicular to this particular resting corner. So we're going to rotate this in such a way that one of the edges parallel to the horizontal plane or the vertical plane, that is the reference line. So this is the initial resting condition. So now we shall annotate the top view of the pentagon. So this is corner A on which it is resting, corner B, corner C, corner D, and corner E. So now we will take. So now we have got a pentagon resting on one of its corner A here, and then we need to draw a perpendicular bisector from the corner A towards the opposite edge, that is CD. So what we will do is we'll select the line option. So from the corner A, we shall try to intersect the midpoint of this edge. So you can just see this. This is the midpoint, and we have completed drawing the perpendicular of this, followed by the endpoint of this projection line. Now we shall annotate the front view of the lamina. So this is A dash, and here corner B dash is visible first. E dash is not visible, so inside the bracket. And this is corner C dash M dash. It is D dash. We need not have to annotate M because we know that AM is a imaginary entity. So D dash. So the corners is visible. Okay, so now this completes the front view of the pentagonal lamina, resting on one of its corners on the HP. So now we'll go for constructing the second condition, that is the surface of the lamina is inclined at an angle of 30 degrees to the horizontal plane. So for that, what we will do is we shall select the front view of the lamina along with the annotations. Select the move option, ensure the copy is on, and then keeping point A dash as the reference, move it on the XY line. Now go for rotate option. So keeping the first point of rotation as A dash and the second point of rotation as C dash D dash, rotate the lamina at an angle of 30 degrees to the HP. Now draw the projection lines. So since the midpoint is on, it is better we switch off the midpoint in the IntelliSketch so that we are drawing the projection lines only from the required corners. So draw the projection from the corners C dash and D dash. Similarly from the corners B dash, E dash, and also from the corner A dash. Okay, so these should be the projection lines. So change the thickness of the lines to 0.13. Similarly, draw the projection lines to complete the top view. So corner E is here, corner B is on this line. Similarly, corner D is on this line, corner C is here. Similarly, from AM to A, it is here. So now we will complete the top view of the pentagon lamina when it is inclined to the HP at an angle of 30 degrees, which is 30 degrees. And now using the line option, let us complete the top view of the pentagonal lamina. So corner D, corner C to corner B, corner A, corner E, and from corner E to corner B. So this completes the pentagonal lamina. Now using the trim option, trim the portions of the projection lines which is not required to us. And also for time being, we shall be uh, using the trim option to trim this projection line so that we get the measurement of this perpendicular bisector in the distorted position. So for that, you can go for distance between, select the endpoints, and then show the distance. Also show the distance of one of the edges of the pentagonal lamina, that is 25 mm. And also here, this is the length of the perpendicular bisector in the initial condition. So you can see that in the second position, this length has been changed. That is AM is not equal to AM1. Okay, so let me call this point as M1. And this parameter is the one which is going to be used for aligning it with respect to the vertical plane, and hence it becomes a beta angle problem because we are going to use a entity which is changing its dimension. So obviously the angle given is not the beta angle, it is the angle phi, and we need to find the apparent inclination of the entity. So for that, we shall construct the beta angle. So the procedure for constructing the beta angle: select a projection line and draw a line of any arbitrary length, and from any arbitrary point, draw a line of length 38.47, inclined at an angle of minus 45 degrees, that is the angle phi. From the end point of this line, let us draw the locus line. So select the dotted lines and draw the locus line which is parallel to the reference line. This is the reference line. So we can just show the angle between this line and this line. Okay, so this is 45 degrees. So to make it more understandable, let us annotate this point as A and this point as M. So AM, so this is the locus of M. Now to get the beta angle, select the tangent arc, the arc by center point, and keeping point A as the center of the arc, cut an arc of radii 33.32 in such a way that, so we'll change the line color here so that it is visible clearly. So we'll make it a red line. So now the length of the line should be 33.32, which is the length of AM here. So now cut an arc in such a way that it is going to intersect the locus of M. Okay, so now using the line option, let us select this point of intersection of the arc and the locus line and join it to the point A. So this red line is going to indicate that it is the beta angle. So we'll measure the beta angle, so which comes to be around 55 degrees. So this is the beta angle. So we will annotate the top view of this pentagon. This is corner A, this is corner B, corner C, corner D, and corner E. So now we can use the extend to next and extend this line. So this is the problem when you use the smart dimension. So better delete this and use the distance between option. So select point M and point A. So we'll be getting the distance. Okay, so now we will do the inclination of the lamina with respect to the VP. So for that, let us select the line option, draw a line of any arbitrary length. Let us change the color to black and ensure it is a continuous line, but a thickness of 0.13. So from any arbitrary point on the reference line, let us draw a line of any arbitrary length, but the angle of inclination must be 55. So what I'll do here is 180 minus 180 plus 55. Okay, so this angle will be 55 obviously. So you can just measure the angle. So this is 55. And now we will select the second position of the pentagon and make it rigid first, along with the annotations and the perpendicular bisector, that is AM1. We shall select the pentagon, make it rigid, tell accept, and now select the lamina again for moving it towards the 55-degree line. So we have selected the pentagonal lamina along with the median. So select the move option, ensure the copy is on. So keeping point A as the reference, place the point A on this 55-degree line. So you can just see that it is turning out to be red, correct? And now we shall use the rotate option. First point of rotation is point A. Next point of rotation is M1. So this is how you can just rotate the pentagonal lamina on this 55-degree line such that its perpendicular bisector is inclined at an angle of 55 degrees to the vertical plane. So now using the line option, draw the projection lines in the front plane from each of the corners and intersect that with the projections from the top view of the pentagonal lamina. Ensure all the projection lines are exactly 90 degrees. So now let us complete the front view of the pentagonal lamina by selecting a line of thickness 0.50 mm. So we shall start with the point A, then point B or the corner B, and then okay, so the point A is here. So this is the corner A. From corner A to corner B. Similarly, from corner B to corner C, corner C to corner D, D to corner E, and then back to A. So this completes the front view when one of its the perpendicular bisector is inclined at an angle of 55 degrees to the vertical plane. So we shall complete the annotation part. So this is corner A dash, this is corner B dash, corner C, and this is corner D dash, and this is corner E dash. So ensure that all the endpoints are met properly using the zoom in and the zoom out options. We can use the trim option to trim the projection lines of unnecessary length. So now this is the construction of the beta angle, and this beta angle has been used here to incline the pentagonal lamina on the perpendicular bisector from the corner to the edge opposite to the resting corner. Okay, so we shall use the leader option to indicate the direction of the projection lines. In the properties, change the color of the arrow to black, click OK, and indicate the direction of the projection lines. So with this, we complete the problem. So to sum up, initially a pentagonal lamina is resting on one of its corner, that is corner A, and then we have drawn the top view and the front view of the pentagonal lamina, and then we are considering the perpendicular bisector through the corner on which it is resting to the edge opposite to that corner. So this is the point M, which is going to bisect the edge CD into two equal halves, and then this edge is going to change its length in the second position whenever it is inclined to the HP at an angle of 30 degrees, and this diagonal or the perpendicular bisector is inclined to the vertical plane at an angle of 55 degrees. So this is the beta angle, and this completes the top view of the pentagonal lamina and the front view of the pentagonal lamina. So this is the solution for the given problem statement. Thank you all for watching.